Welcome back to another AP Pure Calculus video. In this video, we are doing the topic 3.10 part 2 worksheet B on trig equations and inequalities. So hopefully you watched part 1. I hope you understand part 2 a little bit more and that you've gone over the notes. I don't have a video of the notes, but you've gone over it. So yeah. Now this is a worksheet. So let's go ahead and get started. So what are all the values of theta, where theta is greater than or equal to 0, but also less than 2 pi, for which sine of theta is greater than or equal to square root of 3 over 2. So we know that sine of theta is square root of 3 over 2 at pi over 3. Right here, we know the coordinate of that one is this. So we want to know where is the sine greater than or equal to square root of 3 over 2. So we know sine. Is sine x or y? Sine is y. So because we're doing sine, we can kind of go based off of the y-axis here. Which way is the y-axis would be greater than, like which way, right? Because the y-axis we have increases here, but then it decreases this way, right? But I did forget one thing, that there are two values where sine is equal to square root of 3 over 2. It would also be over here because quadrant 2 is also positive, right? So we have that. And now with these two, it's either here or here. Which way is it? Would it fit the greater than or equal to sign, right? There we can use this y-axis here. Are the values bigger here or are the values bigger here? It's this, right? So it would be here. And to write that in the form, it would be using a close bracket, pi over 3, our first value, to our second value, and then close bracket, because we do include that because of this sign right here. So now number 2, we have cosine of theta is less than 1/2. So where on the graph is cosine 1/2? Cosine's positive at quadrant 1 and quadrant 4. So I can label that 1/2. It's at pi over 3. So here and here. That sign is negative, but we don't care for that. We're looking for the cosine. And cosine is also x. So looking at the x-axis for help here, let me plot these 2 points. Would it be less than on this side or less than on this side? It would be this side, right? Because think of this x-axis, right? It gets smaller going this way, but then it gets bigger going this way. So to write that in answer form, we'll be using a closed bracket because it's only less than be pi over 3 to 5 pi over 3. These for number 1 and 2, you can also write it as number 1. You can also write it as this. So it's 2 ways. Number 2, you can also write it as this. So both of these ways work. Whatever you like the best, obviously. So number 3 here. Let f of x is equal to sine of x for all values of x in the xy plane. For this, same thing. For which f of x is greater than or equal to negative square root of 2 over 2. So f of x is also sine of x, so I'm going to replace that. It's not equal to though, it's greater than or equal to square root of 2 over 2, and it's a negative. So where on the unit circle is square root of 2 over 2 and it's negative? So I know square root of 2 over 2 is pi over 4, but negative is, sine is negative on quadrant 3 and quadrant 4. So it would be here and here. So I'm going to write the coordinates there. Right? So we can see it's negative square root of 2 over 2. Now we want it greater than or equal to. So sine, aka the y value, so let's look at the y-axis. Is it greater than here or here? It would be going this way, right? So it would be this section right here. But we cannot just write, 5 pi over 4 to 7 pi over 4. That you're technically saying this section down here, right? Because it's going from least to greatest. This right here is totally different. So what we do want to write, and because of this right here, We cannot include 2 pi, but we can include 0. So we want to start at 0 and then go all the way to 5 pi, our first value. And are we going to use a closed bracket or open bracket there? Let's look back at here. We're going to be using a closed bracket. We can include these values, so we can also include 0, so close bracket at 0. 0 to 5 pi over 4, and then close bracket there. Then when you have multiple, you want to do the u thing, and 7 pi over 4, comma 2 pi. But yes, we can include 2 pi, so close bracket. So that's one way you can write it, but you can also write it like this. But it's a lot more writing it like this. But, I mean, whatever way your teacher said, I guess. Alright, so that's number 3. So, for question number 4 and 5, similar to the first 3, except we are given 2 equations. Yep, so we have to set them like this, which is what I did there, and then solve for sine of x, which I got -1/2. Then I found where -1/2 is on the unit circle there, and then found out which section is sine of x, or the y-axis, less than -1/2, which is below. And this was the sign here. It was just less than, so it had to be open dots. And yeah, it became like that, or you could write it like that. So let's do number 5. So where h of x is less than or equal to k of x. So now I want to move the cosine to one side, so I'm gonna minus this. You could obviously do it the other way, but yeah. Now divide by -2. That leaves us with that, except we divided by a negative number, so that means we have to change our sign. All we have to do is change it the other direction, nothing else. Alright, it should be looking like that. Now we want to find out where on the unit circle is cosine 1/2. We know the coordinate should look like this, and we know cosine is negative at quadrant 2 and quadrant 3. So let's draw this right here is pi over 3. Pi over 3 is here. Pi over 3. So quadrant 2 is looking like right there, and quadrant 3 is looking like right there. So quadrant 2, that's 6, 7, 8. That's 2 pi over 3 then. 8 pi over 12 simplifies to this. And then here we have 18, 17, 16. So 16 pi over 12 simplifies to 4 pi over 3. And so from that, these are our 2 points here, right? So we want it greater than or equal to -1/2. Cosine, we could also think of it as the x-axis. So this side is greater than, or this side is greater than. This side is greater than, right? So we're going to use a closed dot this time because it's greater than or equal to. So it's this side right here. That's our answer, right? But the thing is, it goes through 0 or pi over 2. So we have to start at 0 first. 0 to our first value, 2 pi over 3. And then we have 4 pi over 3 to 2 pi. Yeah. Because if we just wrote 2 pi over 3 to 4 pi over 3, it would be this side right here, which is not our answer. That would be less than or equal to. So that's our answer, but you can also write it as. And that's our answer for number 5. So number 6 and below, we have the problems where you have to do this number line thing. If you remember all the way back from Unit 1, we might have done it in Unit 2, but I'm not recalling it at this moment. So yeah, this number line is a lot of work. Basically, we got our answer just like normal from like part 1. Then we put them onto the number line. Then we had to find values in between the two values to see if they would equal positive or negative. And from that, we would know if it would be above 0 or below 0, because we're solving for it if it's we're solving based on 0, right? For this one, we want it below 0, so we're finding the negative. So it's these two. And because it's not equal to, this right here is our answer. So let's try number 7 here. That looks pretty complicated, but we got this. So, okay, so they both are greater than or equal to 0, and then we can do that there. So I'm going to separate them here. Alright, and then do each side here. So for this side, I can just do square root of 0, which is just 0. So sine 0 is greater than or equal to 0. And that would be these two coordinates. So those two coordinates, and I know this one is 0 to pi. For this kind of problem, they accept both, so it's going to be both. And then this one right here is pi. So for this side, it's equal to 0, pi, and 2 pi. I'm a bit laggy. Alright, and so for this side now, cosine is greater than or equal to positive square root of 2 over 2. And I know that one has the values of a denominator of 4. And it's cosine positive, so that's quadrant 1 and quadrant 4. So that'd be pi over 4, and then the other one would be quadrant 4. If I look at like this unit circle right here, it's 18, 19, 20, 21. So it's 21 because I know it's pi over 4, which is the middle. So 21 pi over 12 simplifies to 7 pi over 4. Now we have our 5 values here. Now we have to put it into the number line. Alright, so 0 to 2 pi. So we already used 0 and 2 pi. Now we have pi over 4, and 7 pi over 4. So I know that pi over 4 goes first. There's 3 values, so I like to cut it down in the middle first. Pi's in the middle. This one's pi over 4, and this one is 7 pi over 4. Now we have to find values in between. We can like sketch like a small unit circle down here. That's very small. It kind of has to do. Pi over 4 we know is right here. So pi over 4 and 0, that's between these two. I know pi over 6 is in between, so we can do pi over 6. So now we have to plug in the values with the original one right here. Or you can look here. But anyways, sine square root, or to the power of 2 of pi over 6. So it basically, we just want to know if it's a positive or negative. We don't need to know the exact values. So sine without this to the power of 2 is going to be the same charge. So sine of that to the power of 6, it might be a bigger number, but it's still going to be, looks like it's going to be a positive because it's in quadrant 1, so it's going to be a positive, times this right here. We have cosine of pi over 6 would be square root of 3 over 2. Square root of 3 over 2 times 2. That's just square root of 3. So square root of 3 minus square root of 2. That would be a positive number because it's above 0, and then that gives me positive. So now over here we have a value between pi over 4 and pi over 3, or between pi. We always want to go like simple because so the accesses, they always have like 0s and 1s. So I like to do that. So that's pi over 2. Actually, I'm going to write down the values I used. So for like this one, I used pi over 6. This one, I'm going to use pi over 2. So sine of pi over 2, that's automatically going to give me a positive because I know the sign is always positive there. And then for cosine, that's 0. 2 times 0 is 0. So 0 minus square root of 2 would be negative square root of 2. So that's negative. Negative times positive gives me a negative. So now from pi to 7 pi over 4, I know 7 pi over 4 is right here. So an easy value is right here. This one right here is 3 pi over 2. So 3 pi over 2, sine of 3 pi over 2 is negative. So, but when you square root a negative, that becomes a positive. So positive. So actually, yeah, these two values right here, they're positive, but positive to the square root of positive times positive is still positive, but negative times a negative is also positive. So whenever you see an even power, that's positive, but if it's an odd, the negatives would become positive. Hopefully that makes sense. Yeah. So that's positive times. The cosine of this is 0, so that becomes a negative. So it's negative, and then this one to 2 pi is right here, so I know this value right here, which is 11 pi over 6, so 11 pi over 6, or just negative pi over 6. So that one, the sign is also negative, but negative to the power of 2 is positive, times cosine of that is square root of 3 times, or the square root of 3 over 2, which I remember, times 2 is just the square root of 3. Square root of 3 minus square root of 2 is positive. So that's going to be positive. And if we look back, are we looking for the positive or negative? We're looking for the positives. So it would be here and here, which brings me to the answer of, this and this. But because we're dealing with an equal to, right? And these are all the values we got. We've included 0, 2 pi, pi over 4, and 7 pi over 4 in our answer. We also have to include pi in our answer. The way we can say pi with this version of the answer is to just write this. We can write pi twice. So that's one way to answer it. Then the other way is, I'm going to have to write this really small. So that's the answer for number 7. Alright, so for number 8, here's the work here. Basically just the same steps as 6 and the one we just did. And then this was the answer we got. And just so you know, these are ors. So it's this or that. So number 9, we have this right here. And I can see that we can factor out a cosine. So I'm gonna go ahead and do that. And now that's 2 that we can split up there. So on this side, the left side, cosine of theta is greater than 0. This side, cosine squared theta is greater than 1 over 2. So then we gotta square root that to get rid of that 2. And so that would equal cosine of theta is greater than or equal, or just greater than square root of 1 over square root of 2, but plus or minus. So square root of 1 is just 1. So I'm actually going to undo that so it's just 1. So it looks like that. The radical is at the bottom, so we can change it so that the radical goes to the top. By doing that, we've multiplied both by that. So it'd be square root of 2 over 2 plus or minus, because the bottom is just square root of 4, which becomes 2. So for that, let's go back to the left side. That would be the values for that side. Would just be pi over 2 and 3 pi over 2. And then the values on the right side would be all the denominators of 4 because it's plus or minus. Right, and now we want to check it on the number line. 0 and then 2 pi. Then we have all of these values. So first one goes pi over 4, and then pi over 2, then 3 pi over 4, then 5 pi over 4, and then 3 pi over 2. Then I'm gonna give a little bit more space. This one right here, 7 pi over 4. Now that's a lot to check. All you have to do is plug it into this one right here. Just plug it back into that. We know that in between here it should be a positive, so positive. And then it's a positive. Then you have to subtract square root of 2, that would become a positive. And then it's 100% greater than 1. So then it's a positive, so it becomes positive. This one becomes, the first one's obviously positive. Starting here though, because x values, they start to become negative here, so that's negative, negative, and then negative. But then now the x values here, they become positive again, and then positive. All of those values were just cosine. We're just the left side that I plugged in, but the right side, that one's a little more difficult. But once you do get it, and then you plug it in, this one will become a negative, this one's a negative, this one is positive, this one's negative, this one's negative, and this one is positive. Then I would get negative, positive, negative, positive, negative, negative. We're looking for greater than 0, so positive, and we're looking for the positive ones, which is this, this, and this. And it is greater than, so I made one mistake. This one should be positive right there, and that's positive. I'm really sorry. So that's our answer. I'm gonna write it in the way with the arrows. So it would be, yeah, I'm really sorry that my answers, they kind of are like a mix of everything, but I want to try to get a mix of everything. But it's not that hard to change your answer in the other way. Just use the brackets or the arrows. When you use the bracket though, make sure you, instead of writing or, you're writing the letter U in between. So I'm not doing any underlines because there's no equal to. Alright, and then that one, that's the answer. That is a lot, and yeah, that was kind of bad, but yeah. So number 10 right here, to get this, I like to use the slip and slide method, is where I slide that 2 over and multiply with that. And I wrote it down right here. I used that to get these two values, so what multiplies to -10 but adds to +9, which were +10 and -1. Then when I get that, I need to make sure that I get that 2 back and then divide both by 2, and I get this. Then I use this to solve for the signs, which those are the values I got. The left side had no solution. The right side had pi/6 and 5pi/6. Then I plugged it into the, I'm gonna move this up here. Because the left side had no solution, I didn't worry about it. I just used the right side to plug in. Then I got negative, positive, negative, and then I only used a positive. That was my answer. You can also write it as know this, obviously. That should be really simple. So, and that was 3.10 part 2, which is definitely more difficult than part 1. So, thank you for watching, and hopefully this video helped.